Hello students, welcome to Saurav's classes. Today we are going to continue with real analysis. Okay, we were doing that in this topic. We are going to do real analysis today. Okay, and the next part of real analysis we are going to continue. Today, in the previous video we had spoken about Cauchy sequence, right? Cauchy sequence. And we had also spoken about convergent sequence. Okay, today we are going to speak about something else, and today's topic would start with divergent sequences. Divergent and divergent sequences. So what is a divergent sequence? Any sequence xn, if it tends to positive infinity or negative infinity, divergent sequence are any sequence of xn if it tends to positive infinity or negative infinity, that sequence is said to diverge. That sequence is said to diverge. So let me give you an example on this. How would you find a divergent sequence? Let's say example, this is how a divergent sequence will look. Say x of n is equal to n square. Let's start putting some values. X of 1 is 1, x of 2 is 4, x of 3 is 9, and so on, right until positive infinity, right? So this sequence is a divergent sequence. This sequence is a divergent sequence. Let's give you another example on a divergent sequence. Say example number 2. Say x of n is equal to minus n square. So now what do you get? Now when you start putting values, you're going to get 1 here, then over here x1, sorry. So here x2, you're going to get minus 4, then x3, you're going to get minus 9, and so on. So this is tending to negative infinity, hence this is also a divergent sequence. Alright, so these two examples are showing you divergent sequences. Now let's go on to the next type. The next type would be oscillatory sequence. Oscillatory sequence. Oscillatory sequence. Any sequence that does not converge, to any point, or it does not diverge is called oscillatory sequence. SEQ, writing in short. Oscillatory sequence. What would be the example of an oscillatory sequence? So let's give you an example. xn minus 1 to the power n. So this is an oscillatory sequence. One more example. xn minus 1 to the power n into n. Okay, so they are both oscillatory sequences. You can start putting values for n here and here, and you will see that the sequence will oscillate. Okay, now let's go on to a few results on divergent sequence. Now the divergent sequence has a few results that you should know. So whenever you see these results in an exam, don't get confused. Just you know that these results have been taught to you, and you can quickly write it instead of thinking what to do. So there are a few results on divergent sequences that I'm going to write. Not many, only three of them. Okay, so write results on divergent. Results on divergent sequence. First one. Okay, a sequence tending to infinity is bounded below. Okay, that's the first one. Second one, a sequence tending to negative infinity is bounded above. Okay, now these two are very simple. The third one is the main important one. Okay, let us take two sequences xn and an. If any one of them diverges, then we cannot say anything about the sum, difference, diff I am writing, product, prod, and division of both the sequences. Okay, so what does this mean? It means that if a sequence, let's say xn is taken, and if I take another sequence an, then will when I add them, when I add this and this, will both of them converge? So your answer will be, I don't know. Will this difference converge or diverge? I don't know. Will their product converge or diverge? You don't know. Will the division converge or diverge? You don't know. So in other words, you cannot say whether their sum, these two sequences sum, will diverge or converge if any one of them is a divergent sequence. Okay, so nothing can be told about the sum and difference and product and division of these two sequences. Okay, and now if I show you some examples, then you'll understand what I'm trying to say. So watch what I'm going to show you. I'm going to show you some examples, some nice examples on this. let me show you some example. Let's say example number 1. Okay, if I take a sequence an, and if I say that this sequence tends to infinity, and if I take another sequence bn, and if I say that this tends to minus infinity, then I want to ask is, not I don't want to ask is, I want to show you. So this and this, but an plus bn is convergent. Can you see that this one is divergent, this one is divergent, but the addition is going to be convergent? So look very carefully. Okay, so let's say I want to take the sequence an as n and bn as minus n. So now when I do an plus bn, then I get n minus n, that is a 0. So an plus bn is convergent. Alright, I hope you have understood this first example. Let's go on to the second one. Okay, example number 2. Example number 2 is, let's say if the same thing I write, this sequence is infinity, tending to infinity, and another sequence is tending to minus infinity. Okay, another sequence is tending to minus infinity. But it may happen, but an plus bn diverges to minus infinity. How? Let me show you. Let's say I take the an sequence as n, and I take the bn sequence as, say, 2n, minus 2n, sorry. So if I take that as minus 2n, then this will be an plus bn will give me n minus 2n, that is minus n. So you can easily see that an plus bn diverges to negative infinity. Okay, let's go on to the third example. The third example would be, let's say again the same thing, an tends to infinity and bn tends to negative infinity. Alright, so an is tending to infinity and bn is, no, bn will not tend to infinity. One sec. Bn will not tend to infinity, minus infinity. How can it tend to minus infinity? Otherwise we won't get the third. So we won't get the third one example properly. bn will tend to, bn is tending to some a point which is finite. Okay, it's not tending to infinity, it is tending to some finite point a. Okay, but an dot bn is divergent. So let us check how this an dot bn is going to be divergent. So let me take an as n square and bn as 1 by n. Okay, so very simple to understand this. Okay, now when you do the product, that is an dot bn, that is n square divided by n, that is n, which is tending to infinity. So what I can write, an dot bn diverges. Okay, diverges. So let us just keep it till point number 3 today, till the example number 3. We will continue with the examples in the next video. Okay, so let us just go ahead and re-evaluate whatever we have done for today. So we have spoken about divergent sequences. Alright, we spoke about divergent sequences. How? I told you that if any sequence x of n tending to positive infinity or negative infinity will diverge. Okay, I have given you an example down here, like xn tending to n square is diverging, and another one down here, xn tending to minus n square, is also diverging. Okay, now next one, oscillatory sequence. What does oscillatory sequence say? It does not converge to any point, neither does it diverge. It does not converge to any point or does not even diverge. It keeps oscillating between 2 points. So here is an example of oscillatory sequence, and another example is here. Okay, then a few results on divergent sequences. What? If a sequence is tending to positive infinity, is bounded below. If a sequence is tending to negative infinity, is bounded above. Okay, and if I have taken, for the third point, if I have taken two sequences an and xn, then I cannot say anything about the sum, difference, product or division of the sequences. Make sure you know this part. It should be highlighted. So they can be anything, either diverge, either converge, the addition, subtraction, division and all. Okay, then a few examples how an is tending to infinity, bn is tending to minus infinity, but when we are adding an and bn, it is converging, right? Again, second example, an is tending to infinity, bn is tending to negative infinity. When we are adding them, they are converging to the negative infinity, right? Third one, a is tending to infinity, bn is tending to some point a. Now when we multiply these two, we see the final result is diverging. We multiply, the final result is diverging. That's what we wanted to know, that an dot bn will diverge or not. So we can see there that it is diverging. It diverges. Okay, so that's it for today. Keep taking as much help as possible, because always the help that you need will be provided at Soros's classes. Thank you very much.